Okay, that's finished earlier what we have from the last video. So last question, what percent make 75 million or more? Right, we will think about that will be 75 more here, right? But be careful. Here, for this region, that will be 25 to 85 million. But it doesn't mean they will be evenly distributed like that. Okay, so that's why here, one thing is, right, we still need to find out what is the percentage covered from here. So for example, like this one look like 0.2, right? So the 0.2 times 60, so that's about 12% here. But one thing is that doesn't mean they will distribute evenly. So that's why over 75 million more, we don't know what exactly. So actually they will become, they actually can be between 12% or even 0% of that. So that's actually, this one is a trick question. Okay, so let's review about the histogram. So then actually I want to finish this video for the other important topic. So one thing is, remember like earlier we say for the Python programming, table and array is very important thing. And also simulation, we have you need to know how to do the simulation. We have some function for different kind of sample. So then we show you the histogram. It's very important to understand the meaning for the histogram. So then also we spend some time to talk about calculating chances. So basically we talk about the probability. Okay, so whenever you do the probability problem, the first important thing, you need to understand what the question is and to see all the possibility. So then all the possibility, that means what kind of cases is the outcome you're looking for. So then we add the possibility on that. So for example, we quickly see the example will be easier. So for example, here we show you have the marbles. So they have different color. Maybe they just have the green and the red. So we say you have 4G and 6 red. So we draw 3 at random. Okay, be careful. Always see with replacement or not. So with replacement, that means every time you draw, then you put it back. Okay, so that's why. So that's why you will see here. If they are all the 3, they are all G. So that's why each G is 4 out of 10. So we do 3 times. So actually it's exponent of 3. So then with OR, so that's you were using the red. So then you will have 6 out of 10. So do the 3 times as well. Okay. So then all the same color. So that's why this one is like I say, you need to see what kind of outcome you have. All the same color. They can be OG or OR. So that's why when you have 2 different outcomes, you need to calculate each possibility. Then we what? Then we add together. So on the other hand, earlier we already have OG and OR, so we add together. Okay, so sometimes when you see at least 1G, that's mean what? So then you have at least 1G, that's mean there are no impossible without G. So that's why it's 1 minus no G. On the other hand, that's equal to 1 minus, because no G, that's mean, yeah, all of them there are R. Okay, so that's the probability. So the probability, be careful, is like I say, every question when they ask you, find all the possible outcome. So each possible outcome, actually, we need to add each chance together. Okay, so that's for probability. So actually, I do want to spend more time to talk about the testing hypothesis. Okay, so we talk about many different ways to testing hypothesis. Okay, so then, of course, when you do the hypothesis testing, that means we have a model we want to evaluate that we can accept that or reject that. So all the model we try to evaluate, so we try to make our null hypothesis statement. So then they will completely specify chance model under which you can simulate the data. So then we will have the alternative hypothesis that will be opposite viewpoint for that question. So in order to do the testing, we need to do a simulation. But how to do a simulation? You need to find out which test statistic you can use. So that will help you to decide which of these two hypotheses is better supported by the data. So we either reject the null hypothesis or we accept the null hypothesis. Okay, so after we choose our test statistic, then we do our simulation. So after we have our simulation, we have our histogram. So after our histogram, according to the observed data, we will calculate that observed data for the equivalent p-value. Okay, so here I want you to make sure you really understand the p-value very well. So the p-value actually is what? So the p-value actually came from under the null hypothesis. We're using the test statistic. We do the simulation. So then we do have observed data we can compare to. Okay, so this observed data we need to know because this one is what is a histogram. So according to the observed data, we can know what is the percentage below that or the percentage above that. So it really depends on where is your tail you're looking for. So sometimes if we're looking for the smaller data, so of course we focus on here. So on the left tail, from here, that's all the smaller value, smaller than the observed data. So according to here, the value we can find because the location, then we can find the frequency, how many data under the tail here. So then we divide by the whole sample data. So of course we know the percentage. So according to this p-value, we will decide do we reject or accept the hypothesis. Okay, so that's why we say, if the p-value too low, okay, so that means is under the 5%. So then we will favor our alternative. Okay, so then we will reject our null hypothesis. But how do we decide the p-value is too high or too low? Actually, we do have our cutoff value, right? So most of the time we use 5%, but all decide by your testing. Okay, so you can decide your cutoff. So here we talk about the cutoff actually is according to how you choose. Okay, so this often already being decided before the data being collected. So before your simulation, you should decide your cutoff is 5% or 1%. Okay, so then we can know the p-value falling into that 5% or not. So we decide to reject or accept on the null hypothesis. Okay, so here this one is very important. I want you to pay attention on that. Okay, so they say which of the following statement does the p-value depend on? Okay, so the p-value actually depends on because we do the simulation under the null hypothesis. And also according to your alternative hypothesis, we know which tail we are looking for. Then of course the choice of your test statistic is how we will get our histogram. And the data in the sample will affect the p-value as well because we need to compare this observed data to calculate as a p-value. So that's why all of that's the p-value depends on, but not the cutoff value. Because like earlier we said, the cutoff actually is, before we do the testing, we already decide how much we can accept. So this value only decide we reject or accept the hypothesis according to where the p-value fall into. But the cutoff is not affect the p-value result. Okay, so this one is very important. So I hope you can, I want you to make sure you pay attention on that. Okay, so we only have 5 minutes left. So that's why I want to quickly to talk about the A/B testing. Okay, so remember this week we talked about the more testing. That's we will decide our causality or not. So this one, because we have the two different group, we have the control group and the experiment group. So since we have two different group, right? So that is the A/B testing. So it's very important when we do the causality testing, we need to have a randomized control experiment. So this experiment, we have two group. So that's we say you have two samples. So that's why it's A/B testing. We have control group, we have treatment group. So the treatment group and control group are selected at random. Because they are selected at random, that's why at the end, when we make the conclusion, we can see they are causal conclusion or not. So any difference in outcome between the two groups, they only due to the chance in the treatment. Okay, so that's very important how we can do the causality hypothesis testing. Okay, so remember when we decide the population, okay, so for example, here we have a sample, participant is 31 sample. From this experiment, actually, magically, we don't know which one they are. We just think about they have random pick ticket to assign this 31 sample. So then we have 16 ticket is for the control group and 15 for the treatment group. So then after we do here, right? So of course, our null hypothesis, we always have state the two group have no different result. Okay, so of course your alternative will be they are different. Okay, so that's why all the potential treatment scored, they both are in unknown distribution. Okay, so then either treatment group or control group. Okay, so then after we do the data testing, okay, so that's why you can see here the null hypothesis, the distribution of the 31 potential control score is the same as the distribution of all the 31 potential treatment scored. Okay, so they are the same. So then your alternative, we will say the 31 potential treatment scored, they have, you can say either higher percent. It really depends on your testing. Okay, so we just need to see they are different. Okay, so that's why after you have your test, okay, so your test, if they reject the null hypothesis, so that of course the data favor the conclusion that the treatment help. Okay, so this one actually is we got is causal conclusion due to the random assignment. Okay, but really be careful is even we make the conclusion right, this conclusion is only according to this 30 sample. If we want to make the conclusion is in the greater sample, then you need to have a bigger data to be collected. Okay, so that's why you can see here, just quickly to make sure you know how you will prepare for your midterm exam. Okay, so we have few different topic, but the most important thing is besides you go over this handout, we also provide you the midterm review worksheet. So actually this one is very important. I want you to make sure before you know, you need to go over your lab exercise and example. Okay, your lab exercise and your assignment, and go over your textbook and make your own note. But this one actually is a very good example you can see here. Because one thing is I want you to know how to prepare your final exam is we actually give you some topic you can go over, right? So you see the first one, table is important, right? So then we will give you a table so you see how to manipulate some data we want to looking for. Then histogram, so how you need to understand the meaning for histogram and each bin, the data you need to know how to calculate. Then of course we have some question about the probability. Okay, so then we have some question definitely about the simulation and hypothesis testing. Okay, so then you see here, then we have some question about function, about the Python function. Okay, so that's why in this sample midterm exam worksheet, it's really help you to prepare for the direction for your midterm exam. And also our midterm exam will also fall into similar format like here. So we will have a different topic. We'll have tables, we have the Python programming, we have the simulation, we have the hypothesis testing. Then we will have the histogram. Okay, so then those questions can be in fill in blank, or multiple choice, or multiple answer, or matching question. Okay, yeah, so here's what I want to show you. Yeah, so your midterm exam will be on Monday next week. Also, we cover module, the first 8 module, and textbook is 1 to 12. So it's open book, open note. You can use your Jubic Hub. Okay. But one thing is, make sure you have your notes ready before you start the midterm exam. Then we have 36 questions in different formats. They can be multiple choice, multiple answer, matching question, or fill in blank and short answer question. So the total is 100 points. Then you have 2 hours to work on that. So please make sure you study with your peer group and work on your midterm worksheet. That will be very helpful for your midterm exam. So good luck for everyone. Okay.